On the morning of August 30th, 2025, a powerful earthquake struck the Nevada desert near the small town of Valmy, west central Elko County. The first reports pegged it at magnitude 5.3. That made it the strongest quake ever recorded in this immediate area in modern history, shattering the old record of magnitude 4.7 from 1962. Later, after more readings came in, the U.S. Geological Survey revised it down slightly to magnitude 4.7 to 4.8, but by then the message was clear. Something extraordinary had just happened in Nevada, and this was no one-off. Over just a few days, more than 20 separate tremors rattled the desert floor, most of them between magnitude 2.5 and 3.8. The biggest struck just before noon, shallow, only about 6 to 8 kilometers deep, making it widely felt. Shaking reports came in from as far away as Boise, Idaho, hundreds of miles away. This wasn't just an earthquake, this was a swarm, and it was happening in a place that had no mapped major fault line. The swarm began quietly. In the pre-dawn hours of August 30th, seismographs picked up a cluster of 7 small quakes. The largest at that time was only 3.5 around 12:28 a.m. Locals may have rolled over in bed and shrugged it off, but the earth wasn't finished. As daylight broke, the tremors grew stronger with multiple 3+ jolts leading up to the late morning quake that peaked at 5.3 on initial instruments. Seismologists note that revising quake magnitudes is normal. Automatic readings in the first minutes often overshoot. But revision doesn't take away the fact the ground beneath northern Nevada had unleashed the strongest shake in living memory for this area. And here's the unnerving part. These quakes didn't happen on any of Nevada's known faults. Instead, they came from a buried fracture that scientists hadn't mapped, a ghost fault. When most people think of earthquakes in the US, they think of California, the San Andreas Fault, the Bay Area, Los Angeles. But Nevada's no stranger to seismic activity. In fact, after California and Alaska, Nevada ranks 3rd in the nation for earthquake activity. That's because Nevada sits in the Basin and Range Province, a massive geologic region stretching across the western US. It's not stable, far from it. The crust here is literally being pulled apart. Imagine the continent slowly unzipping, with jagged mountain ranges as the teeth of the zipper and flat desert valleys between them. Every single year, the basin and range stretches wider by about 1 to 2 millimeters. That doesn't sound like much, but on a continental scale, it's enormous. Over millions of years, it has built entire mountain chains and carved wide basins. This constant stretching leaves the land riddled with faults, hundreds of them. Some are mapped, many are not, which is why the August swarm was so alarming. It happened where there shouldn't have been a quake at all, at least according to the maps. Now, earthquake swarms themselves aren't rare. Yellowstone, for example, logs thousands of tiny quakes a year, often clustered in swarms. But Nevada's late August swarm was different. For one, it was stronger. Instead of microquakes, the sequence included multiple jolts in the magnitude 3 to 4 range, capped by the 5-class main shock. Second, the pattern didn't look like a typical main shock and aftershocks. Normally, you get one big quake followed by smaller ones that taper off, but here the ground kept rumbling at similar magnitudes for hours, then days. Rather than winding down, it seemed to be recharging. One U.S. Geological Survey scientist put it simply, "This isn't behaving like a normal sequence." That's chilling language in seismology, a field where uncertainty is already the rule. Let's talk history. Nevada may not have California's fame when it comes to quakes, but it has produced monsters. The 1915 Pleasant Valley earthquake was a magnitude 7.1, ripping a scar across the desert floor. In some places, the ground shifted 6 feet in an instant. That quake was felt from San Francisco to Salt Lake City. Luckily, Nevada was sparsely populated at the time. Damage was limited mostly to ranches, but if a quake of that size struck today, it would tear through highways, power lines, and growing cities like Reno and Las Vegas. And that's what makes this current swarm so unnerving. It's happening in an area that had, until now, been considered relatively quiet. The largest quake locals remembered was from more than 60 years ago, that 4.7 in 1962. Now, suddenly, the ground has produced a sequence that matches or exceeds that event, and it's on a fault no one even knew existed. Think about the implications. Our seismic hazard maps, the tools engineers and city planners rely on to decide where to build, are based on known faults. Faults we can trace on the surface or identify through decades of fieldwork and satellite imaging. And yet, here we are, watching a hidden crack in the earth come alive. This isn't the first time either. Back in 2011, a 5.8 quake in Virginia shook the entire East Coast, cracking the Washington Monument. That quake, like Nevada's, happened on a fault no one had mapped clearly. It stunned people because the East Coast wasn't supposed to shake like that. But it did, and now Nevada has its own ghost fault writing a new chapter. Scientists are racing to understand what happened. They've deployed portable seismometers around Valmy. They're analyzing radar satellites for signs of the ground shifting. Early results suggest the swarm ruptured along a buried fault several kilometers long. But here's the scary part. They don't yet know how far it extends. If it's deeper or longer than expected, it could be capable of much larger quakes. And that's the real danger. Because in a place like Nevada, where the crust is actively tearing apart, a hidden fault today could be tomorrow's rupture zone. So here's the big question. Was this swarm just an oddity, or is it a warning shot? Scientists won't say it's the precursor to a big one. That kind of prediction isn't possible. But they will say this: swarms on unknown faults are the hardest to predict. They don't come with a long history of behavior. We don't know how often they rupture. We don't know how much stress they can hold. And we don't know what their breaking point looks like. That uncertainty is the haunting reality of Nevada's August swarm. It wasn't just about the quakes that already shook the desert. It's about the possibility that something bigger is still coming. To really understand why Nevada is shaking, you need to see the bigger picture. This part of the continent, the Basin and Range Province, is one of the most geologically restless zones in North America. From eastern California through Nevada and into Utah, the crust is literally being stretched apart. This slow-motion stretch is why Nevada has so many faults, more than 1,500 mapped across the state, and why it ranks third in the U.S. for earthquake activity, behind only Alaska and California. But the August 2025 swarm introduced something new, a crack we didn't know about, opening in a place we thought was quiet. Scientists call this a blind fault. Unlike the San Andreas, which carves a visible line across California, blind faults are buried under layers of rock and sediment. They don't advertise themselves. They sit in silence for decades, sometimes centuries, until one day they rupture. And that's what makes them dangerous. You can't prepare for what you can't see. Nevada's swarm was a perfect example. And while no buildings collapsed, thanks to the remote location, the quake was strong enough to surpass the 1962 record holder of 4.7, making it the largest event in that area's modern history. The silence of centuries had ended in a matter of hours. So what does this mean for the rest of Nevada? And for the country? Let's talk about the state's seismic resume. Nevada has a long history of violent quakes, even if most people don't know it. The 1915 Pleasant Valley earthquake, magnitude 7.1, tore a 35-mile-long rupture across the desert, shifting the ground up to 6 feet. In 1932, the Cedar Mountain quake struck at magnitude 7.2, one of the largest in U.S. history. And in 1954, the Fairview Peak and Dixie Valley doublet unleashed back-to-back 7.0-plus earthquakes that permanently altered the landscape. So while Nevada's deserts look empty and still, the ground beneath them has a violent memory. Today, though, Nevada is no longer empty. Reno has nearly 270,000 residents, Las Vegas over 640,000, and highways like I-80 run straight through the swarm region. A quake the size of Pleasant Valley today would be catastrophic, not just a scar in the desert, but a blow to the infrastructure that connects the West. But what unsettles scientists most isn't the history, it's the pattern. Normally, earthquakes relieve stress. A fault slips, energy is released, and the crust resets, at least for a while. But swarms like Nevada's suggest something else. Instead of one clean break, the crust is grinding, adjusting in fits and starts like gears slipping under pressure. And when a fault doesn't release all its built up stress, the fear is that it's storing it for something bigger. That's why the U.S. Geological Survey rushed to deploy extra seismometers around Valmy. They need to know if this swarm is tapering off or if it's just the beginning. Because if it's the beginning, Nevada may be staring at a precursor event, a warning shot from the Earth. The problem is, science can't give a definitive answer. Earthquakes are one of the last natural hazards we can't forecast with precision. Meteorologists can track a hurricane days in advance. Volcano observatories can often detect magma rising before an eruption. But earthquakes, we only know the odds. And the odds in Nevada are not comforting. The USGS puts the likelihood of a magnitude 6.5 or larger quake in Nevada within the next 50 years at more than 50%. That's basically a coin flip. For a magnitude 7 or larger, the chance is smaller but still significant. And remember, Nevada's risk isn't concentrated in one fault like California's San Andreas. It's spread across dozens of zones, many unmapped. That makes the threat diffuse, harder to prepare for, and more likely to catch us by surprise. Let's step even further back. The western U.S. is a patchwork of tectonic forces colliding. To the west, the Pacific Plate grinds past the North American Plate along the San Andreas system. To the east, the stable interior of the continent resists. And in between, right where Nevada sits, the crust stretches, warps, and cracks. Geologists describe it as a zone of weakness. Imagine a piece of glass under stress. It doesn't break at the strongest part. It shatters where it's thinnest, most fragile. For North America, Nevada is one of those fragile places. That's why seismologists sometimes call the basin and range America's weak zone. The August swarm was a reminder that the weakness is alive, that even in places where the maps are blank, the Earth can still tear open. And it leaves us with an unsettling question. If one ghost fault can awaken out of nowhere,